We've been following the saga of 3I Atlas for months. Its discovery, its hyper-fast trajectory, its unusual behavior. But now something new has emerged, something that shakes the foundation of how we interpret comets. On October 29th, around the time of its perihelion, scientists detected an unexplained non-gravitational acceleration in 3I Atlas. In other words, it didn't just follow the gravity rules. It appears to have been nudged by something else. This isn't another routine comet update. This could be a clue to unknown physics or even unknown technology. Today, we're going to walk you through the latest findings, the background anomalies, and what to watch for in December. Stay tuned. Here's what happened. Around its closest approach to the Sun, data from observatories showed 3I Atlas deviating from its predicted path. According to analysis, the object was found about 4 arcseconds away from where models had placed it. To put that into perspective, 1 arcsecond is 1/3600th of 1 degree. 4 arcseconds can translate to tens or hundreds of kilometers of deviation in space at that scale. That's huge for an object whose motion we track precisely. What that indicates is something beyond gravity is influencing its motion. Traditional trajectories account for solar gravity, planetary perturbations, solar radiation pressure, but here the shift is stronger. In parallel, solar observing satellites like SOHO and Stereo recorded a sudden brightening of the comet and a noticeable shift in its color, turning bluer than the sun. These changes add to the puzzle. Scientists now count this as the 9th recorded anomaly in the 3I Atlas file, a growing dossier. What caused the acceleration? What caused the color change? These questions are now urgent. In standard comet science, when a comet nears the sun, its ices sublimate, gas jets erupt, dust is ejected, and these jets act like tiny thrusters, nudging the comet off its pure gravity path. That's non-gravitational acceleration. But for 3I Atlas to attribute the measured deviation solely to gas jets, we'd expect a massive release of mass, on the order of billions of tons. Some estimates put it at over 5 billion tons of ejected material. Yet, and here's the crux, we still haven't identified the expected debris cloud. Where is the mass loss cloud? That absence raises a key question. Could the acceleration be occurring without the expected mass ejection signature? If so, we may be looking at a 10th anomaly, acceleration without debris, which would break many of the standard comet physics rules. Adding fuel to the mystery, 3I Atlas is scheduled to have a close approach to Earth on December 19, 2025. That window becomes a test. If the debris is present, we'll spot it. If not, the object's behavior may defy all conventional explanations. Enter Avi Lowe, who has taken a keen interest in 3I Atlas oddities. One area he specifically highlights is gravitational lensing, because 3I Atlas passed close to the sun's gravity can bend light from stars behind the object. By measuring that deflection, one can infer the object's internal density and structure. Lowe calculates a possible 0.27 arcsecond deflection for light passing near the object, measurable with modern instruments. Why does this matter? If we can determine 3I Atlas internal density and compare it with typical comet nuclei, we might discriminate between natural icy rocky bodies and something that is artificially dense. Loeb argues that if 3I Atlas has a significantly higher density than normal comets, it could hint at artificial materials or construction. If proven, this could redefine how we measure and interpret distant interstellar bodies. Let's walk through each of the 9 major anomalies in the 3I Atlas case. 1. Impossible trajectory. 3I Atlas follows a retrograde orbit aligned within about 5 degrees of the solar ecliptic, remarkably aligned given it comes from interstellar space. The probability of random alignment that close is estimated at approximately 0.2%. 2. Solar jet pointing toward the sun. Instead of a tail blown away from the sun, 3I Atlas displayed a jet or tail directed toward the sun, precisely opposite of standard solar wind behavior. No prior comet has reliably exhibited such a sunward jet. 3. Gigantic size plus unusual speed. While comets vary in size and speed, 3I Atlas appears unusually massive and moves faster than expected for a typical comet from our solar neighborhood. The analogy, the heavy truck moving faster than a sports bike, is inconsistent with energy expectations. The probability of this combination is estimated below 0.1%. 4. Perfect planetary timing. Its path brought it near Mars, Venus, and Jupiter in quick sequence, all while hidden from Earth view behind the Sun. The probability of 3 cosmic darts thrown and all hitting their marks is estimated at approximately 0.005%. 5. Strange metallic composition. Spectroscopic data suggests nickel to iron ratios closer to industrial alloys than natural cosmic dust. Probability under approximately 1% for natural formation in normal comet environments. 6. Lack of water. 3I Atlas shows only approximately 4% water content, making it far more rocky and dry than typical comets. It's like finding an iceberg composed mostly of rock, not ice. 7. Extreme negative polarization. Light reflected off 3I Atlas exhibits unmatched polarization patterns. No natural surface surveyed so far replicates this. The way the reflected waves twist is outside standard comet models. 8. Wild signal direction. Its incoming trajectory aligns within approximately 9 degrees of the origin of the 1977 wild signal from Earth's radio astronomy history. The coincidence probability estimated at approximately 0.6%. While not proof of anything, it adds another unexpected piece. 9. Blue brightening near perihelion. As it approached the Sun, 3I Atlas not only brightened rapidly, but also turned bluer than the Sun. Typical comets redden under heat absorption, so this is unusual and marks the 9th confirmed anomaly in the dossier. Here's where the tension peaks. If 3I Atlas acceleration is due to comet-style outgassing, then we should see massive mass loss, dust and gas ejections visible to telescopes. The December 19, 2025 close approach to Earth becomes the turning point. If no debris cloud is observed, then 3I Atlas might become the first object accelerating without visible matter loss. That would challenge our concept of comets entirely. Observational teams will use infrared imaging to detect dust, spectroscopy for gas, and high-resolution tracking for trajectory deviation. Mark this date. The outcome may rewrite cometary science or even our understanding of interstellar objects. Within the scientific community, there's clear division. Many traditional astronomers argue that 3I Atlas is simply an extreme comet. Unusual, yes, but natural. For example, NASA has stated it behaves like a comet despite oddities. On the other hand, theorists like Avi Loeb argue that when data doesn't fit existing models, we must be ready to revise the model. One blog post by Loeb states, when data doesn't fit the theory, it's time to revise the theory. Why the restraint from declaring alien technology? Reputation risk, the burden of proof, no direct evidence of engineering, from Galileo to Einstein. Paradigm shifts required bold claims backed by repeatable data. Today's question: is this an extraordinary claim or an extraordinary event? Either way, studying it is science at its best. If you've been following this deep space mystery so far, take a moment to subscribe and turn on notifications. We're tracking every new image, data release, and theory surrounding space exploration, so when the next update drops, you'll want to be the first to know. Let's consider 4 balanced hypotheses. 1. Artificial technology. 3I Atlas is a probe or spacecraft, perhaps using a light sail or other propulsion system. The acceleration without mass loss and high density could fit this scenario. 2. Natural yet unknown object, perhaps a new class of interstellar object, metal-rich, volatile pore, icy shell long eroded, something we haven't seen before. 3. Hybrid theory. A natural object significantly altered by radiation, collisions, or interstellar travel, giving it artificial-like properties without being manufactured. 4. Observational illusion. Errors in measurement, solar glare interference, or mismodeling could create apparent anomalies that will vanish with more data. Which is correct? Right now, the evidence doesn't settle it, but December's observation window could. Let's say if 3I Atlas is indeed engineered, it would mean advanced civilizations capable of interstellar travel exist, and they've sent probes into our neighborhood. The motives could be many: exploration, reconnaissance, even passive monitoring. Even without proof, this possibility forces humanity to expand its perspective on intelligent life, cosmic traffic, and our place in the galaxy. It also prompts deeper investment in planetary defense and interstellar object monitoring. Whether natural or artificial, 3-Eye Atlas has already changed the conversation. So I ask you, what do you think 3-Eye Atlas is? A comet, a probe, or something we've never imagined? December will bring more data. Stay curious, stay alert, because the cosmos may be speaking louder than we think. So make sure you subscribe for our December follow-up, where we'll break down the new observation data as it comes in. Until then, keep your eyes on the skies, stay curious, and remember, every mystery out there brings us one step closer to understanding who we are in the vast universe.